Today, we'll be looking into the process of naming of acids. So, acids, they usually are two different types. One types of acids, they are called as binary acids, and the other ones are called as oxoacids. And as the name indicates, the oxoacids, they have oxygen present in them, whereas binary acids have no oxygen in them. So oxygen atoms are not present at all, and these ones, they have oxygen atoms. Now, first we look into the process of naming of binary acids. So binary acids are formed with a combination between an H positive ion and a negatively charged ion, which usually will end in an ide. Let us take an example. So we have HCl. If we try to break it down, it is made up of H positive and Cl negative. So we can see that the negatively charged ion does not have any oxygen atom in it. So we are going to be considering it as a binary acid. Now, how to name it? So if it is a binary acid, we always have to use a prefix, which is hydro. So that's the first thing you have to do. And then we have to look into which is the ion, negatively charged ion actually, which is involved in the formation of this acid. So we have the negatively charged ion, which is chloride. From this chloride, we are going to leave out the suffix ide. So we'll mention chlor, and just because it's an acid, so the IDA is going to be replaced by IC always, and then use acid at the end. The process is very simple. Replace the IDE with IC. Introduce the prefix hydro, and just because it's an acid, so you have to place acid at the end. So this HCl will be named as hydrochloric acid. Let us take another example. HCN. Again, let us break it down. So this breaks down into H positive and Cn negative. Now the Cn negative, if you look into the polyatomic list, it is called as cyanide ion. Again, it is ending with the ide. So because we have to name this acid, so we'll start with hydro, just because it is a binary acid. And then the IDE is going to be replaced by ic. So cyanic and then acid. I'm again repeating the process because it's a binary acid. So you have to introduce the prefix hydro, and then from the ide, which is an ion, you're going to replace it by ic and add the suffix acid. So this becomes hydrocyanic acid. For the naming of oxoacids, the process is a little bit different. So let us look into the process. Now, for oxoacids, you have to be careful because they have polyatomic ions. I'm taking the first example of an acid over here, so which is HClO3. If you break it down, it is made up of H positive and ClO3 with a 1 negative charge. The ClO3 with a 1 negative charge, this ion is called as chlorate ion. We know that this is an oxoacid as it has got oxygen in it. So any oxoacid, as I've already told you, they'll contain oxygen, and when we are naming them, we do not use hydro. That's the first important thing you need to remember over here. And because this is coming from chlorate, so we just need to replace this 8 with an ick, and it still is chloric, and we have to add acid in the end. So this acid is chloric acid. Remember it? We are just not putting hydro in the front. So no hydro, and this is chloric acid. Chlorine in combination with oxygen can exist in the form of different polyatomic ions. So let us look into that. ClO3 with a 1 negative charge is called as chlorate. If we reduce one oxygen from here, it becomes ClO2 with a 1 negative charge. So we are not changing anything. The only thing I did over here is reduced one oxygen. So instead of calling it as chlorate now, this is called as chlorite. Now, if I reduce one more oxygen over here, so it is ClO with a 1 negative charge, and now this is going to be called as hypochlorite. And if I increase one oxygen into chlorate, which makes it ClO4 with a 1 negative charge, this is called as perchlorate. So you can see that the chlorine in combination with different number of oxygen atoms can form different polyatomic ions having oxygen. So what we just need to know is the formula for chlorate. And once we know the formula for chlorate, we can make the formula, or we can derive the formula for the chlorite, the hypochlorite, and the perchlorate. So you don't need to learn like all of them. The only important polyatomic ions you need to learn, if your teacher does not provide you with the polyatomic ions list, are all the 8s. So chlorate, sulfate, phosphate, nitrate. Those are the ones only which you need to know. I'll just imply the same thing to sulfur with oxygen. So let us look into that also. Now, sulfate is SO4 with a 2 negative charge. So we call it as sulfate. Now, if I remove one oxygen from here, it's going to go as SO3 with a 2 negative charge, which is sulfite now. So the 8 is changed to ite. If I reduce one more oxygen from ite, so it makes it SO2 with a 2 negative charge, I'm going to be calling it as hyposulfite. So here you can see that I added the prefix hypo and I let the rest of it be the same. Now from sulfate we can make persulfate again. So I'm going to take SO4 2 negative and add one oxygen to it, so it makes it SO5 with a 2 negative, and now this will be called as persulfate. So you can see clearly over here that I added the prefix per, and then the rest of it remains the same. It's very easy to just remember the formulas for the other polyatomic ions once you know the formulas for the 8s. So chlorate, nitrate, phosphate, any one of them, you should be able to get the formulas for the other polyatomic ions. Now, this is going to be helpful because then you don't need to learn a lot of polyatomic ions in order to name the acids. If I want to make the acid with perchlorate, chlorate, chlorite, or hypochlorite, the only thing I need to remember is if it is 8, the polyatomic is 8. I'm not going to add any hydro, and the 8 is going to be replaced by ic acid. And if the polyatomic ends in ite, then it is going to be named as us acid. Now, let us try naming HClO4. We know that it is coming from the polyatomic perchlorate. It is an oxy or an oxoacid. So I'll be naming it as perchloric acid. What I did, the 8 over here is replaced by an ic, and perchlorate, when it forms an acid, that acid is going to be called as perchloric acid. If I want to name the acid HClO, which is formed from hypochlorite polyatomic, then again, just because it's an oxyacid, so I'm not going to be writing any prefix. I'll just use hypochlorous acid. So I just replaced this ite with us, and I can easily name the acid. We noticed two things in this lesson. The first was if the acid was a binary acid, then the hydro needs to be introduced as a prefix, and the ide part needs to be replaced by ic, and we just need to put acid at the end. And if the acid is an oxoacid, then no hydro, 8 needs to be replaced with ic acid, and ite needs to be replaced with us acid. There are only two exceptions to this rule, and that's when you have the negatively charged ion of sulfur or of phosphorus. So these are the only two places where there is an exception. Okay, in sulfur, I'm just first making a binary acid, so H2S aqueous, and here I know that just because it's a binary acid, so I have to add hydro. That's the first thing. Now this is formed from S with a 2 negative charge, because S with a 2 negative, sulfide. So sulfide, it's hydro, and we'll replace this ide with ic, and this sulf comes from here, but you can see that there's additional part which I have written down. So UR is something which comes additionally when we are trying to name acids involving sulfur. So this acid is called as hydrosulfuric acid. The same is the case with phosphorus. So if I make an acid, it's going to be H1 positive with P a 3 negative charge. So this is H3P. again aqueous. So we'll put hydro just because it is not an oxoacid, it is a binary acid. We know that this is phosphide. So this ide has to be replaced with ic, but we have to again add something additional. So hydrophos, this much is okay. And then I'm going to be adding ic acid. So did you observe over here that this OR are two additional letters which fit into the name while we are naming the acids which are formed from the negatively charged ions of phosphorus. So this is going to be called as hydrophosphoric acid. So we replace the ide with ic. Phos is written as such, but we add an additional OR. Okay, so the key thing you just have to keep in mind that when we are naming the acids of sulfur, so the rest of the rules apply the same way, except for the difference that we add UR, which is there. This name is there in the name of sulfur, right? And same thing from phosphorus. So OR is additionally added, though it is not present in this monoatomic ion, which is phosphide. So I hope you understood the process. See you in the next video. Bye-bye.